Thank you for coming all to my presentation. My presentation title is Distributed and Parallel Image Processing on Livebook. My name is Wakabayashi. I'm an AI engineer at OEC-CO Ltd. I'm developing AI services with OpenNet IBS. My current interests are data analysis with Elixir, image processing with Elixir, AI development with Elixir, satellite data with Elixir. I'm in Oita, Japan. Oita has a spaceport and the best hot springs in Japan. Many satellites will be launched from Oita spaceport. Please come visit Oita. Why do I process images with Elixir? We, OpenNet IBS, use serverless architecture on AWS. Serverless is cheaper and easier to maintain. The backend is implemented in Python. The front end is implemented in JavaScript, and the mobile app is implemented in Swift. We had to learn many languages. Our tech lead came across this tweet. The tweet said that when they replaced their serverless operation with Elixir, their costs dropped dramatically. We decided to try Elixir. For the backend, we use Phoenix. For the front end, we use L, a functional language like Elixir. However, we couldn't implement AI inference in Elixir, so that part remains in Python. Also, we couldn't make a mobile app in Elixir, so we are still in Swift there too. But Phoenix is running stable and we are happy enough. Following year, our tech lead said, can't everything be developed in Elixir? You don't want to use several languages. I said, Master, are you serious? I investigated the possibility of image processing in Elixir. Then I met Nx and Evision. I fell in love at first sight. Susumu Yamazaki showed me the way at ElixirConf US 2022. We can use Nx and Evision as image processing instead of NumPy and OpenCV. Nx and Evision was the best solution for me. He has shown that a large image can be processed more quickly and safely by separated. And Elixir makes it easy to write robust parallel image processing. And I love Livebook. I used Jupyter to show my team the data. Jupyter is very useful for visualizing the results of an AI model. One of the reasons for Python's popularity is that many researchers and students use Jupyter. But I made Livebook. Goodbye, Jupyter. Goodbye. You can process images with Livebook. And you can visualize the data with Livebook. It is easy to animate images and graphs. Livebook is a very powerful visualization tool, even more so than Jupyter. And Elixir is more concise than Python. Livebook will attract researchers and students from many fields to Elixir. Exactly yesterday, I also introduced Livebook to dozens of students at Oita University. So today, I will show you a Livebook version of the presentation by Susumu Yamazaki. I am running Livebook in a container on my local machine. I will show you image division and concatenation with Livebook. The notebook has already run a setup cell. So this is my notebook, and this is image division notebook. This is setup cell. In Livebook, install dependent modules in the setup cell. It's good to see the dependencies made explicit. Jupyter does not make dependencies explicit. This notebook installs the following modules. Nx, perform matrix operations in Elixir, and Evision, and OpenCV wrapper, process images in Elixir. Waku, downloads the image in this notebook, and Kino, powerful UI UX in notebooks. What to do in this notebook? Divide an image vertically or horizontally and then merge them together. First, download the image of me via Wakabayashi. This is my face. When you load an image with the eVision, the image will appear in the notebook. The automatic display of results is much more convenient than with Jupyter. Then prepare for image processing. Get the file name, extension, and shape with height and color. Next, prepare a function to save a list of divided images. Divide horizontally. Chunk size is number of pixels in width and height of the divided image. eVision map to NX, convert eVision image data to NX tensor, and to batch it, divides the tensor into pieces of the chunk size. And eVision of CV keys colors in BGR order, so invert to RGB. And display divided images. This. I'm divided horizontally. Layout width makes it easy to display images side by side. This code. And DBZ. DBG shows the output of each pipeline. This is original image, and next tensor, and to batch it in screen, and reverse and list of images and display image. Next, save divided images with the prepared function. The file name of the saved images is now displayed. Now, let's concatenate the divided images. Oh, it looks like zombie. The images were concatenated at horizontal split. This color. Invert color for even numbers to show that they were divided. Next, let's divide the image vertically.
Sorry, you can make it bigger so we can see the code.
Oh, sorry. Below. Okay.
Yeah, perfect. Thank you.
Next, divide vertically. Raise image to divide it vertically because Nx to bucket can only split horizontally. So Evision map to Nx, and next Nx transpose swaps the vertical and horizontal, and divide and swap the vertical and horizontal. Let's evaluate. And divided vertically. When Nx transpose is turned off, I'm vertically horizontally. This is why Livebook and DBG works so well together for image processing. And saves in divided images and concatenate divided images. Invert color for even numbers. The images were concatenated and vertical split. And finally, divide the image into tiles. To type, divide both horizontally and vertically. And divide it into tiles. Save divided images and concatenate divided images. And this time, invert color to check pattern. Oh, I'm in a check pattern. Livebook is super powerful visualization tool. Livebook also makes it easy to visualize satellite and geographic data. Next example, parallel image processing. In Elixir, concise parallel processing can be implemented with Flow. Next notebook. It is set up cell. And the following two modules have been added. Flow parallel processing in Elixir and benchmark in Elixir. What to do in this notebook? Process 128 images in parallel and compare the speeds of sequential 1 parallel, 2 parallel, 4 parallel, and 8 parallel processing. Now, get the image with my face, and let's process only one image first. In this notebook, I will shoot the image and draw some rectangles and ellipses. Many rectangles. Then copy images for parallel processing. This copy count is number of copies. Then display the first 6 copied files. It's all same files. And next, sequential processing. Let's try sequential processing with NumMap. Get the list of existing files and process with NumMap. Let's process. All images processed. Display the first 6 copied files. All images processed. Next, let's try parallel processing with format. Replace NumMap to format and insert flow from enumerable before format. Set the number of parallels for stages. Max demand is set to 1 so that flow process all images in parallel. If max demand is not set, flow will group targets for sequential processing and then process each group in parallel. And then display first 6 copy file. Same result as NumMap. Finally, speed comparison. Compare speeds with Benchy. Sequential processing with NumMap and flow map 1 stage, 2 stage, 4 stage, 8 stage. Benchy runs at first NumMap and then flow 1 stage. Hurry up. Now 2 stages. And 4 stages. And now 8 stages. Then it results. So Benchy displays the first test process and how slow the others. NumMap is slowest. And for parallel with flow map is fastest. Because my machine's CPU has 4 cores. So it doesn't make much sense if the number of parallels exceeds this. Next, notebooks on Livebook work as a node. One notebook is one node. Livebook is an easy way to explain distributed processing. So distributed processing is easy with Livebook. Elixir is suitable for distributed processing of huge data such as satellite data. Next notebook, distributed image processing. This is main notebook. What to do in this notebook? Distributed processing of 32 images and comparison of speeds on 1, 2, and 4 nodes. Other nodes, worker 1, worker 2, worker 3, and worker 4. Same notebooks. First, get the image. And next, how to process an image between nodes. Convert an image to binary. This is to exchange images between nodes. Its type and image size and image binary. In this notebook, I will reshoot the image and draw the node name. This is to specify which node the image was processed at. And convert the processing results returned in binary to a matrix. Node name of this notebook is drawn in the image. This is main notebook name. And node connection. Check the connection between notebook as nodes. Currently, this notebook is only connected to the Livebook process. Now, let's connect to a worker notebook. Input the worker 1 node name from worker 1 notebook. This is Kino input text, text input. Node.self in worker 1 node. This is worker 1 node name. Copy it and paste it. Then worker 1 node name is here. And connect to worker 1 node. Then list. Worker 1 node name has been added to the list. And disconnect worker 1 because we will connect later. Worker 1 node name has been removed from the list. Next, copy images for distributed processing. Copy images to 32 images. And display the first 6 copied files, or same images. Next, define the processing module. Define image processing as a module for distributed processing. Send images as binaries from the main node, this notebook, to each worker. Workers convert the binary back to an image and return the result as binaries to the main. Main saves the returned binaries as each images. This module connects the worker node and generates a stream of worker nodes and from up, then receives images from the main and perform image processing and sends the process to images to the main. Process 1 image on own node in this main notebook. This is main notebook name. Then process 1 image on 1 worker node. Same module in worker 1 node, evaluate it. And this is worker 1 node name. So it processes it in worker 1 notebook. Next, process 32 images on the 1 worker node. With the files that exist. Go. All images processed. And Waka1 node name is drawn in all images. Next, process 32 images on 4 Waka nodes. Waka2, Waka3, and Waka4. And copy node names. Waka2, and Waka3, and Waka4. And don't forget, evaluate modules. Okay, this is Waka 1, 2, 3, 4 workers. And process in 4 worker nodes. Node name in images are displayed, indicating that they were processed in distributed processing. Next, speed comparison. Prepare a function to process a given list of workers and compare speeds with different numbers of workers. Now, one worker, Waka1 node only, and next, 2 workers, 1 worker and 2 Waka2. And final 4 workers. Oops. This is results. In reality, the distributed processing was not effective because it was running on a single machine in my local machine. So in the future, I would like to actually run distributed processing on multiple machines. It's my vision of the future. AI, image processing, and data analysis are now Elixir's support. Many modules have already been released. Nx, Evision, Image, Axon, Explorer, and Bumblebee. The front end can be implemented with Phoenix Live View. The mobile and desktop apps can be implemented with Elixir Desktop. So I say, yes, we can develop everything in Elixir. Thank you very much for hearing this presentation.